Hello everyone, my name is Harzira Khalid. In this video, I will show you how electrical energy is generated in nuclear reactor. The running outcomes for this topic is describe generations of electrical energy in nuclear reactor. First and foremost, what is nuclear power plant? A nuclear power plant are a type of power plant that use the process of nuclear fission in order to generate electricity. To do so, they using nuclear reactor combined with Rankine cycle, where the heat generated by the reactor converts water into steam, which spin a turbine and a generator. Nuclear power provides the world with around 11% of its total electricity. The largest producers are United States and France. Aside from the source of heat, nuclear power plants are very similar to coal-fired power plants. However, they require different safety measures since the use of nuclear fuel has vastly different properties from coal or other fossil fuels. They get their thermal power from splitting the nuclei of atoms in their reactor core, with uranium being the dominant choice of fuel in the world today. Other examples of fossil fuel that have potential use in nuclear power production is thorium, but it is not currently in use. Next, let me show you how does nuclear reactor work. This is the basic operations of a boiling water power plant, which shows the many components of a power plant along with the generations of electricity. This figure illustrates what is inside the nuclear core. The nuclear power plant needs to build and design that must follow certain safety features. To prevent any disaster from happening, a nuclear reactor needs to be covered in concrete shielding because the product of fission reaction which can be hazardous. The fuel rods inside the reactor are made of uranium-235 or uranium-238 or plutonium. What exactly happens inside of fuel rod? An incoming neutron splits the uranium or plutonium nucleus. During this process, another neutron will be released and the two neutrons can be moved to cause more fission in other uranium or plutonium nuclei. The chain reaction occurs around this time. The example of chain reaction is as follows. But the problem is, the neutron release move around at very high speed. This makes it difficult for them to be absorbed by nearby fuel rod. So we need a moderator to slow the neutrons down so that state can easily be absorbed. The moderator used in nuclear reactor is graphite or water. Next, too much fission reaction can lead to overheating of the reactor. When the rate of reaction is too high, we need to lower control rod to absorb nutrients and preventing them from traveling between fuel rods. Control rod is raised back when reactions are reduced to a safe rate. Control rods are made from boron or cadmium. After the chain reactions take place in the nuclear reactor, water which acts as a coolant is pumped into the reactor to absorb and transmit the energy out of reactor. A typical nuclear reactor functions at 300 degrees Celsius. After that, water is also pumped into the steam generator. The boiling of water created high-pressure steam and drive a turbine, which in turn rotates a magnet or coil in the generator. The steam will condense into water. The electrical energy generated is sent to consumers via a power supply transmission system. To help you with better understanding of how nuclear reactor is work, let's watch this video.
Nuclear power plants are thermal power stations which generate electrical energy from heat. They consist of numerous buildings and facilities, the most important of which are as follows. The turbine building houses several turbines as well as the generator necessary for electrical power generation. The containment building where the nuclear reactor is housed is made of meter-thick reinforced concrete. Inside this building, nuclear reactions take place where water is heated up. The cooling tower, which can be as tall as 200 meters, is where hot water is cooled. In order to easily understand the underlying principles, the following is a description of the most important components of a nuclear power plant that uses a pressurized water reactor, PWR. In the reactor pressure vessel, the nuclear reaction and the associated release of thermal energy takes place. In a pressurized water reactor, as in this case, the reactor pressure vessel stands about 12 meters tall. The walls are about 25 centimeters thick. Inside is where the fuel assemblies can be found. In pressurized water reactors, about 150 such assemblies are installed. A single fuel assembly is composed of many fuel rods. A fuel rod is about 5 meters in length and has a diameter of about 23 centimeters. The actual nuclear fuel is found inside of each fuel rod. Small nuclear fuel pellets composed of enriched uranium or plutonium make nuclear fission chain reaction possible. In the fission chain reaction, thermal energy is released. Water is needed in order to absorb the thermal energy and keep the chain reaction going. Inside the vessel, the water is heated to over 570 degrees Fahrenheit. The water does not boil, however, since the pressurizer maintains the water pressure constant at around 160 bars. The heated water is eventually pumped to a heat exchanger, also called steam generator. These are typically in the form of a shell and tube heat exchanger. Hot water flows through the U-tubes, heating up the metal of the pipes so that any water inside the heat exchanger begins to boil. The resulting steam is eventually fed through a set of pipes to the turbine building. The steam first drives a high-pressure turbine and then is typically fed to 2 low-pressure turbines. All of the turbines are connected by a spinning shaft to the electrical generator, which in turn produces AC electricity from the shaft's rotational energy. The steam is converted again into liquid form in a condenser, and then returned back to the steam generator. The water needed for this often comes from an adjacent river, or is cooled in a cooling tower. The water circulation systems are always kept separate from one another. Water in the primary circulation system never leaves the containment building. This water is radioactive, since it has been in direct contact with the fuel rods. Water in the secondary circulation system is used to drive the turbines and is not radioactive. The cooling circulation system provides cool water and is used to condense the steam in the secondary circulation system.
So, how do you find the video? Now, let's check your understanding. So, what is the functions of moderator in nuclear reactor? Does everybody know? The functions of moderator in nuclear reactor is to slow down the fast-moving neutrons. Next, too much chain reaction can lead to overheating of the reactor. How to prevent this from happening? Is any one of you want to try? The answer will be lower the control rod to absorb excess neutrons. Next question is, how does a boiling water nuclear fission reactor produce electricity? So the answer is, uranium-235 produces a continuous source of energy through a chain reaction that is controlled by control rods. The energy boils water to create steam, which powers a turbine that turns a generator to produce electricity. This is true or false questions. Solar panels are used to create nuclear energy. So the answer is false. If you are thinking this is true, then you need to check your understanding. Next, this is multiple choice questions. In a nuclear reactor, uranium is forced to A. Join together, B. Explode, C. Break apart, and D. Multiply. Is any one of you want to try? So the answer is break apart. Remember that nuclear reactor use fission reactions. So the fission reaction is to split the nuclei. Last but not least, when an atom split, it releases energy in form of A. Heat energy, B. Warm energy, C. Cold energy, or D. No energy. Can you guess on this one? So the answer is heat energy. In fission reactions, it releases energy that boils water into high pressure steam. To summarize this, nuclear fissions of uranium-235 and its chain reaction produce heat energy. Water is pumped into the reactor core to absorb the heat energy that is produced by the nuclear fissions. The boiling of water produces high pressure steam. This steam will be channeled to the turbine. The turbine is rotated by the high pressure steam, which in turn rotates the magnetic coil in the generator. The steam will condense into water. The electrical energy generated is sent to consumers via a power supply transmission system. That is all from me. I hope you get better understanding about how nuclear reactor plant system is. Thank you for lending your ears. Bye.